Hey guys, this is a bunch of free examples. This is video 1 of 3 where the first derivative is given, and what we're going to be looking at is increasing and decreasing functions and the first derivative test. As a reminder, pause and try the examples when you are prompted, and there are always free guided notes available at divideandconquermath.com. Okay, so in these examples, what I want to do is identify the critical points, identify intervals of increasing and decreasing, and then identify any local or global max or min values, whatever we can do. Okay, so what you're going to be given here is the first derivative, and we're just going to try to answer as much of the questions that we possibly can. Now, I know it's tempting to just start getting your hands dirty with this, but what I really want to recommend actually is that you take a deep breath and just say, what do I know about this before you get started? It's good to kind of notice these things so that you don't end up making a mistake later on. So first of all, you always want to think about what's the domain of the information that you have. So in this case, what's the domain of this first derivative? Well, this is a rational function, so you have to worry about where the denominator is 0. So the domain is all real numbers except for -2 and +4. And then the other thing that you just want to notice is this is where the vertical asymptotes are at -2 and 4. So let's write that down. Okay, so now that we've noted that, we're just going to kind of remember that in the future, and maybe I'll just put like a little star next to this so I can recall that note later on. Okay, so now let's go through this list. First things first, we want to identify the critical points. So the critical points are going to exist at either where the function is 0 or where the function is undefined. And since this is a rational expression, we really have to divide this into two pieces. So where the top equals 0, that's where the function equals 0. So where does the top equal 0? The top equals 0 at x equals 1 and at x equals -5. And where does the denominator equal 0? Where the denominator equals 0 is where this function will be undefined. So we also have the points x equals -2 and x equals +4. So these are all of my critical points. But I already know some information about this before I get too far into this, right? I know that as far as critical points go, there will be no max or min at -2 or 4 because there are asymptotes there. So critical points can tell you all kinds of information, and it's up to you to figure out what that information is. So these could be possible max or mins, but they don't have to be. Okay, so now let's move on to the next part. Identify intervals of increasing and decreasing. So using the domain as a guide, we kind of want to divide up the domain based on the critical points. And we want to organize all this information into a table. Now, I like to do my tables like this, where I write out the interval, and then I just want to note the sign of the derivative at that interval. Now, how do I actually break up this interval? Well, you could imagine the number line as such, and then you can use your critical points to kind of divide up the interval. So going in order with my critical points, I have -5, -2, 1, I say 1 and I write 4, 1 and 4. And so now this is actually how we're going to divide up our intervals. And basically within each interval, the behavior of the function is going to stay consistent. So when I'm in this interval, everything's either going to be increasing or decreasing. You're only going to have a behavior change when a possible behavior change at the critical point. All right, so from here to here, what is this on the number line? Well, this is -∞ to -5. There's my first interval. Now moving on, I go from here to here. This goes from -5 to -2. Okay, continuing on from here to here. This is from -2 to 1. From here to here, this is 1 to 4. And then last but not least, this is 4 to infinity. So now I have all the intervals that I actually need to do my testing on. So I'll get rid of that number line. And the next thing that I want to do is I want to choose a test point in each interval so that I can figure out what the sign of f prime looks like in that interval. And this is going to actually help me get to my intervals of increasing and decreasing now. So just to start here, what would be a good test point that's in this interval? You don't want to choose -5 because we've already established that this is either where the derivative will equal 0 or will be undefined. So you want something that's solidly in the interval. And that's why I put these rounded brackets around, so to kind of tell you to not choose, you know, those numbers at the end. So a good choice in this case would be x equals -6. And so from here, you really just want to know what is the sign of this. So you could plug it in like this, and then you could work it out. And now you can see what the sign of this is. This is positive, so that's what I would put here as a positive mark. But here's the thing. You don't really care what the last number is, so it's kind of up to you if you want to do all of this work. The big thing is you really want to figure out what is the sign of this. And a lot of times you can figure out the sign of the derivative just in the context of the problem and kind of what you know about how calculations will work. So in looking at this, the way that I might think about this is -6 minus 1, this is negative. -6 plus 5, this is negative. -6 plus 2 is negative. And then -6 minus 4 is also negative. So I have all of these negatives being multiplied and divided together, so I can see that the sign would be positive without doing all this work. So this is kind of the idea. So let me clear this off. And let's do one more together for the next interval. So if I choose a number in here now, so a number that is solidly in this interval would be something like x equals -3. So now I have to figure out what is the sign when I take f prime of -3. And once again, I can plug this in. And all I care about here is what the sign is going to be. So if I just go through and think about this, I've got -3 minus 1, that's negative. -3 plus 5, that's negative. -3 plus 2 is negative. Oops, sorry, -3 plus 5 is positive, my bad. Joke's on you guys, I can't do math. And then -3 minus 4 is also negative. So here's all my signs, right? So what's the sign going to be in this interval? All of the other points in this interval will all end up being negative. So this is kind of the idea. So what I want you to do is pause the video and fill in the rest of this chart. So choose your own test points and kind of figure this out, and then hit play when you're ready. Okay, so just to kind of make sure you're on the right track with this now, I'll continue to choose some test points. So here from -2 to 1, probably the best test point in this case would be 0. And if you actually went through and calculated this, you would get that this equals 5/8. So the thing I care about is that this is positive. Then in the next interval, from 1 to 4, so a good choice there might be 2. And again, if you chose something like 3, it totally doesn't matter. It's just you're paying attention to the sign. But if you worked this all out, so I got -7/2, so the sign there is negative. And then for this final interval, so if I choose x equals 5, so in this case, if I plug that in, as I have all of these difficulties writing, this comes out to 36/7. Again, all I care about though is the sign. So however you got to this conclusion is totally fine. You don't even really need all this other work. It's probably a good idea to show, like on a test or something or a quiz, your instructor just what kind of work you did in case you make a sign error with this, because this is going to throw everything off. So something to just kind of keep in mind to prove that you really know what you're talking about. But you know, however you come to these conclusions is up to you, and you just want to make sure you've kind of justified why you think these signs are the way that they are. All right, so now I've really got enough information. Every time one of these signs has a plus sign, that means that we are increasing on the interval, and every time it has a minus sign, that means that we are decreasing. So I can write this out nice and clearly now. And so this is the type of like clarity you want to make sure that you give to your instructor. And if you're one of my students, I definitely want to see you kind of explain this. You don't want to just turn this in. This would be like the equivalent if you were in a job sending this to your boss. That's not something that you want to do. Your boss doesn't care about all of this detail. They want to see that you understand kind of what all the work means. And this would be the kind of information that you would actually give. So I do want you to practice this if you're one of my students and actually write this out. Okay, so this is what? This is actually part 2 that we just completed. So we can keep going. Now I need to identify any local or global max or min values. So let me clear some space and let's go back to this. Okay, so this is where this information up here is going to come in handy. So it's tempting to just say, oh, okay, increasing, decreasing, oh, now I've got, max or min or whatever here, and not really think about it. But this information really matters here. So what I want to do is I just want to protect myself from trying to call these two vertical asymptotes. I don't want to call them max or mins. So I'm going to just put a star here and here, and this is just to remind myself of my note up here as I'm going through this. So now we can use the first derivative test, which I will just remind you of. So you have f is a continuous differentiable function, and we've got the critical points. So let's get to the meat of this. When f prime changes from positive to negative, we have a local maximum. So we have this situation here. And when f prime changes from negative to positive, then we have a local minimum. So we have this situation here. So with that in mind, let's go back to our table now. And so this is going from positive to negative. So this means here that I have a max. So I'm just going to note that. And then from here, I'm going, so nothing here, right? I might have said this goes from negative to positive, so I have a min, but I know it can't be a min because it's a vertical asymptote. All right. So now moving over here, I'm going from positive to negative. So again, this is another max, and actually that's all I can do for this one, right? So I can't go any farther with this. So now once again, I just want to summarize this. And so now it's nice and clear. Now in this problem, since we don't know what f is, I can't really say much more about the local max. I can't say what the value of the maximum is, because I would have to plug these into the original function f, which we don't have. So all we know is that the local max exists here at x equals -5 and x equals 1, but we don't know what the actual maximum is. And you want to make sure that you understand and you make this clarification. You don't want to say that the local maximum is -5, because it's not. It occurs at -5. So it's a little change in how you think about things. Okay, so let's go to the next one. So this is very similar to the last example. So what I want you to do is I've written out the first derivative for you. So think about the domain, just think about if there's any asymptotes, and then I want you to find the critical points. So let's start there and hit play when you're ready. Okay, so here my domain is all real numbers once again, except for x equals 0. And there is also an asymptote really at 0, right? So if I were to rewrite this out, this would be x plus 3 over x to the 1/3. So otherwise my domain is all real numbers, and I'm just going to note here that there's a vertical asymptote at 0. Okay, so we'll probably use this fact again later, so I'll just put a star next to this and we'll recall it. So now what we want to do is find our critical points. So using this form here, so where does the top equal 0? The top equals 0 at -3. And then you might also be thinking, oh, well, what about 0? So that is technically a critical point. But we know what's going to happen here, right? It's not going to be, there's no way this can be a max or min. It has to be a vertical asymptote. So we just have to kind of keep that in the back of our mind. Okay. So now let's go ahead and make our table and determine the signs of our derivative. So I want you to create the entirety of the table with the intervals and everything. If you want, just hit play when you're ready just to check your table setup, and then we'll go from there. Okay, so I'm going to have my interval, and then I want to know my sign of f prime. And so if I use this number line to kind of help me figure out my intervals, so my critical points here were 0 and -3. So my first interval will go from -infinity to 0. And then my next interval will go from, oh gosh, I totally screwed up the order on this. I swear I can do math. All right, let me start that over. Okay, so let me draw that number line again. Okay, so I start here at -3, I go here to 0. One more time with feeling. So going from here to here, so I go -infinity to -3. From here to here, this is -3 to 0. And then last but not least, 0 to infinity. So those would be my intervals. So now what I want you to do, if you haven't yet, is go ahead and fill in the sign of f prime and hit play when you're ready. So I need a test point for each one of these. So I'm not going to show you all of the work for this. You can let me know in the comments if that's something that you'd like to see, but I will just kind of walk you through this process one more time as a reminder. So here you want to choose something that would actually be in this interval, so something like -4. And if you plug in -4, so maybe I will just show this once. So if I plug that into my derivative, so you can see the top will be negative, and then -4 to the 1/3, this will also be negative. So you get a negative over a negative. So this will ultimately give you something positive. Then as I go from -3 to 0, so if I choose something like -1, I would find that this would be now negative, because when you plug this in, the top's going to be positive and the bottom will still be negative. And then finally, if I plug in something positive into this whole thing will end up being something positive. So that's kind of the idea that you want to think through as you do this. And so now we can, of course, come up with our intervals of increasing and decreasing. Okay, so now for the last part, we need to determine the max and min in this case. So let me get rid of this. And I just want to leave that note for myself not to call that a max or min, because we know there's going to be a vertical asymptote there. So instead what I see here is, so I go from positive to negative, so I can see that I have a max here. And so otherwise this is going to say there is a local max at x equals -3. And that's about as much as we can say about this. We really can't make any other conclusions about this because we just don't know what the first derivative is, so we can just confidently say there's a local max. So if you find this helpful, please consider giving my video a like, or subscribing and sharing my channel, or leaving me a comment. Any feedback that you have for me is great. I seriously appreciate it. And I still have 2 other videos. So this was the case where we have a derivative given to us. I have 2 other videos where we have to find the derivative, so you can check those out in the next part of the series. So thanks for watching, guys.